Higher order derivatives. Okay. So if we have, you're in physics class, right? We all love physics. Yes. Okay. And you do, is it physics 11 when you do the little ticker tape thing? You have the car and it shoots down the ramp, and then the ticker tape, and then you count, you measure the dots, dot, 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 like that. All right. And then you plot it, and you have your position, like distance from the start or whatever it is, and then you have your time. Yes? Remember all this? And then you got a curve, and then everybody drew a tangent line, and everybody's tangent line was different, and everybody got different velocities, right? Okay. Well, this leads to what the derivative is. What does the derivative represent?
Slope at the exact point.
The slope at the exact point of the tangent line. If the slope is rise over run, right? This is your tangent line. And it has slope of rise over run. The rise is measured in what units? Meters. The up down is meters, right? Or centimeters, but we put an M there, so we're going to go with meters. And the run, the xy, is measured in meters per second is. Wow, that's very unison. And the slope of the tangent line in calculus is called the. What's this unit called? Derivative. So therefore, f prime of this case, it would be t for time, is equal to the velocity function. The first derivative represents velocity. So we would say v of t. V of t. If you do the second derivative of the position function, f is the position function. I guess we should say that. F of t equals the position function. So you take the first derivative of the position function, you get v of t, the velocity. The second derivative of the position function, so we call that f double prime of t. F two little primes. Maybe I'll do this in a different color so we can see it. F double prime of t, which is the derivative of the velocity function, v primed, is equal to the acceleration, a of t. So second derivative represents acceleration. Those are the ones you're going to use the most common. Those are the most common ones, but there is more. You can just keep doing it. So if you wrote it out and you went f of t is position, f prime is velocity, f double prime is acceleration, f triple prime, we talked about this yesterday, is called the jerk. It's how fast you are accelerating. It's the acceleration of the acceleration. And then it keeps going. Now, once you get past triple prime, they don't write, like, just keep putting primes. You can write in Roman numerals like that, or you could just write f4 of t. So that's the fourth derivative. That is called the snap. F5 of t is called the crackle, because mathematicians are so fun. And F6 is called the pop. So it goes snap, crackle, pop. You can keep doing derivatives as long as you want. Okay? Now let's talk about notation, because everybody loves notation. we say dy dx is the first derivative, right?
Yeah, like when you add milk, it like pops. And they
Are we
call it-
talking about the? Are we talking about Rice Krispies right now?
Oh, because it's like that's a derivative of milk.
All right. So dy dx is the first derivative, or f primed. And then you do f double prime, f triple prime, you can do that. But if you're writing it in terms of dy dx, what they do is they write d squared y over dx squared. This means the second derivative. Okay, so if you see that notation, it's the second derivative. So that would be f double prime of x. We only really deal with up to maybe 4, but in physics, you could use them all. But for the physics that you'll see most of the time, well, you don't even do calculus in physics, do you? Yeah. The math outstrips the science. You'll do calculus in university physics. Or not. So that's the notation. Now, let's look at polynomials. So polynomial functions. If I have a polynomial of f of x is equal to 3x cubed plus 2x squared plus 1. And we start doing derivatives. Do you know what I mean when I say a polynomial? No negative exponents on a polynomial and no radical or fractional exponents, okay? So they're all whole number integer exponents. Or positive integer exponents, I should say. If you do the first derivative, what's the first derivative of this function? Plus 4x. And then we do the second derivative. And then we do the third derivative. And then you do the fourth derivative. Oh my gosh. It goes to 0. And then the derivative of 0 is 0 because it's a constant, right? So look at the degree of the polynomial. What's the degree of the polynomial? How many derivatives do I have to do to get to 0? Plus 1. It's the degree plus 1. Okay, now that's for polynomial functions. If you're doing a trig function, so let's do, we'll do sine. F of x is equal to sine x. What's f prime? It's f double prime. Sorry, what is it? Negative sine of x. F triple prime. And f fourth is back to sine. So every 4 derivatives, you cycle back. Okay? So the classic question on a first year calc is if f of x, oh, we don't know chain rule yet. Can't tell you that question. Sorry. So just know every 4 derivatives it cycles back, but we don't know chain rule yet. Sorry, I just realized that. Polynomials will always go to 0. It's just going to be the degree plus 1 is how many derivatives you have to do. So if I said, we'll just do a polynomial. If I said your polynomial was x to the 100, which derivative does it go to 0? F of 101x will equal 0. Okay, that makes sense? That's all it is. It's the degree plus 1 for polynomials, not for trig and not for rationals. If you have negative exponents, that doesn't work. For polynomial ones. All right. Page 127, numbers 91 to 97, 115, 129, 131, 133. Remember, you're only doing the odds. And that's the end of today. Yeah. So let me stop this video here. Why aren't we stopping?